Hey guys, what are you guys doing?
Hi now, we're just about to start studying matrices.
Oh, matrices. Did you guys understand the lesson just now?
Oh, do you mean about the problem solving using inverse matrix?
Yes, that one. Can you teach me a little bit about it?
Of course, let's learn it together.
Hello you guys, let's learn together on how we can solve equation using system inverse matrices. Here are the 3 steps to get you started. First, you need to convert the equation in Ax equal to B, and you need to find the inverse of matrix A, and you need to find x. We're gonna look at it one by one. For the equation in the form of Ax equal to B, I have given you the example. Given the equation x minus 2y equal to 5, 4x minus 3y minus z equal to 3, 5y minus 7z equal to 9, you can turn it in the form of Ax equal to B as shown. Next, you need to find inverse matrix A as you have learned it in the past subtopics. There's 4 components in finding inverse matrix A, which is determinant matrix A, cofactor matrix A, adjoint matrix A, and last but not least, inverse matrix A. For determinant matrix A, you need to choose only one row or one column, and as for me, I choose first row. So, I got the answer for determinant matrix A, negative 30. For cofactor matrix A, you need to cross out the row and the column chosen, and you need to calculate the determinant of the submatrix. Also, don't forget to determine the sign factor, whether positive 1 or negative 1. Then, you have to repeat it 9 times to get cofactor 3 by 3. Next, we need to find adjoint matrix of A. Bear in mind that adjoint matrix of A is equal to the transpose of cofactor. The transpose of a matrix is found by interchanging its rows into columns or columns into rows. Next, you need to find the inverse matrix of A through a formula 1 over determinant of A times adjoint of A, or equal to C transpose. Next, you need to find x. Bear in mind that the element of x is x, y, and z. So through a formula Ax equal to B, both sides multiply with A inverse, you get the formula x equal to A inverse B. So our last steps is the simple process where A inverse times with B, and you will get the answer. You can try it out first and check the video to see if your answer is correct.
This is how you solve an equation using inverse matrix. Oh, it's not that hard. Anyway, I bought some snack at Coke just now, but I don't know how much an item costs.
What did you bought?
I bought porridge, chocolate, and cake.
Well, I think we bought the same thing.
Yeah. Delivery here. Thank you.
Thank you.
Thank you.
Can we solve it using inverse matrix?
Yes, really.
Let's try it out.
To solve problem by using matrix, we firstly need to find the linear equation regarding questions. Let's assume that x is the price for chocolate, y is the price for cake, and z is the price for porridge. In this situation, I now bought 2 chocolate, 3 cakes, and 1 porridge for 11 ringgit. So the equation would be 2x plus 3y plus z is equal to 11. Where Aisha bought a chocolate, 2 cakes, and 2 porridge for 12 ringgit. So the equation would be x plus 2y plus 2z is equal to 12. Awada bought 2 chocolate, 4 cakes, and a porridge for 12 ringgit. So the equation for Awada would be 2x plus 4y plus z is equal to 12. Next, we need to rewrite the equation in form of Ax equals to B, where A is the coefficient, x is the variable, and B is the total price for each individual. From AX equals to B, we need to find X as the subject. To eliminate A, we need to multiply both sides with A inverse, where A inverse multiples by A will result in identity. Now that we have X is equal to A inverse B, the next step in solving this equation is by finding A inverse. Firstly, we need to find the determinant. From row 1, determinant could be found by using this equation. From the equation, we need to substitute the value of A11 with 2 and C11 with negative 1 power of 1 plus 1 and minor of 1 1, where minor of 1 1 is equals to 2 2 4 1. Repeat the same step for A12 and A13, where minor for A12 is 1 2 2 1 and minor for 13 is 1 2 2 4. Simplify the equation and we will get the determinant of A is equals to negative 3. The next step is to find cofactor. For C11, we will have negative 1 power of 1 plus 1 multiplied by minor 1 1, where minor 1 1 is 2 2 4 1. Minor for 1 2 is 1 2 2 1 and minor for 1 3 is 1 2 2 4. Repeat the same step for each of the element in matrix A. Simplify each of the expression and we will get cofactor of A is negative 6, 3 0, 1 0 negative 2 and 4 negative 3 1. Then we need to find C transpose. To find C transpose, we need to exchange the position of column and row for the cofactor. So we will get C transpose as negative 6, 1 4, 3 0 negative 3 and 0 negative 2 1. Now that we have C transpose, we could easily determine the value of adjoint A, where C transpose is equals to adjoint A. This would be the last step of finding A inverse. To get A inverse of A, we need to use the following equation, where A inverse is equals to 1 over determinant of A multiplied by adjoint A. Substitute the value of determinant of A with negative 3 and adjoint A as the following. Simplify and we will get the A inverse. Now we can substitute the value of A inverse into the equation of X equal to A inverse B. Solve the following by multiplying A inverse to B and we will get matrix of 3 1. Thus, we can identify the value of each variable where X is equals to 2, Y equals to 1 and Z is equal to 4. Based on the value of X, Y, Z obtained, we know that price for a chocolate is 2 ringgit, price for a cake is 1 ringgit and price for a porridge is 4 ringgit.
Now we know cost for each item. We know that a cake costs 1 ringgit, a chocolate costs 2 ringgit and a porridge costs 4 ringgit.
Oh, I see. By the way, what are the other examples that can we use to solve system of linear using matrices? Can we solve this?
What is that?
These are my money that I've been collecting for a week. I want to get 80 ringgit by the end of this week and I noticed my 10 cents is twice the number of my 20 cents and the amount of coin that I have is 82 coins. But I want to know the exact number of my 10 cents, 20 cents and 50 cents. Can we solve it using inverse matrix?
So now let's help Awada solving her problems. First, we can assume that X is the amount of 10 cents, Y is the amount of 20 cents and Z is the amount of 50 cents. From the video earlier, we know that Awada has saved a total of 18 ringgit. So we can write it as 0.1x plus 0.2y plus 0.5z equals to 18. And the amount of 10 cents is twice the amount of 20 cents. So x is equals to 2z. And the amount of coins that Awada has is 82. So we can write it as x plus y plus z equals to 82. So now we got 3 linear equations and we can proceed with the matrix. To solve the equations using matrices, we need to write the equations in the form of Ax equals to b. From the equation of Ax equals to b, we can find that x is equal to the inverse of AB. So now let's find the inverse of A. To find the inverse of A, we must first find the determinant of A. For this case, we choose the second row to find the determinant of A. We can write that determinant of A equals to A21 C21 plus A22 C22 plus A23 C23. So now we just need to substitute and calculate the determinant. Therefore, the determinant of A is equals to 0.1. Now, we need to find the cofactor of A. To find cofactor A, we need to calculate the cofactor of each row and column. Substitute and calculate the cofactor. So now we got the cofactor of A equals to 2, negative 3, 1, 3 over 10, negative 2 over 5, 1 over 10, negative 2 over 5, 7 over 10, and negative 1 over 5. To find inverse A, we must also know the adjoint of A. We know that C transpose is the same thing as adjoint A. From cofactor A, we can deduce cofactor transpose by changing the row and column. So now we know that adjoint A equals to the matrix of 2, 3 over 10, negative 2 over 5, negative 3, negative 2 over 5, 7 over 10, 1, 1 over 10, and negative 1 over 5. So now we can substitute the determinant of A and adjoint A into the equation of inverse A equals to 1 over determinant of A multiplied with adjoint A. Thus, inverse of A equals to the matrix of 20, 3, negative 4, negative 30, negative 4, 7, 10, 1, negative 2. Finally, after finding the inverse of A, we now can find the unknown with the equation of x equals to inverse A, B. Substitute the inverse of A and B to find x, y, and z. So now we got that x is equal to the matrix of 32, 34, and 16. Therefore, x is equal to 32, y is equal to 34, and z is equal to 16. Now we know that our dad has saved 32 number of 10 cents, 34 number of 20 cents, and 16 number of 50 cents.
So this is how we use inverse matrix in our daily life.
Ha! Do you get it?